Okay, exercise. The first one we did today. 2, 4 minus 1, 0 minus 2, 0. I want you to do this again. Choose a row, does not matter which one. Choose a column. I shouldn't say doesn't matter. I should say there are good choices and then there are better choices. So pause, copy, try. Pause, copy, try. Okay, the best choice, either the third column or the third row. Why? Because of the zeros. These zeros are your friends. Hopefully not in real life, but in determinants, the zeros are your friends. So I will choose, for fun, I'll use the last column. Doot doot, booty boop. So what does that mean? It means that I have 0 times some determinant, but I do not care, right? Because it's multiplied by 0, I'm not even going to write it down. In this column, the only thing I have to think about is this minus 1, right? So minus 1, I go 1, 5, 0, minus 2. Did I get my pluses and minuses right? Let's see. I think I did. Oh, no, I didn't. I did not. I was not being very clear. I have a minus. It should go right here. So I get 1 times minus 2, which is negative 2, as expected. Now, I want to repeat. This is worth repeating. I chose the third column because there are lots of zeros. Because I had a 0 here, I just totally didn't even write the first term. Usually there are three terms here, 1, 2, 3. But if I have a 0 right there, then there's no sense in writing the term. So I don't write the term for this guy. If I don't write the term for this guy, because they're going to be 0. So I only write the term for that one. I put the minus here because of my plus minus diagram. And there we go. Okay, so lots of zeros make us happy. Exercise. Let's try a 4x4. Mm-hmm. Mathy math. 4x4. Let me see. You know what? I'll just do this one example. Okay, looking at all the zeros I have here, choosing the first column is a good idea. So I'll make my little diagram over here. Okay, 4x4 is where it becomes important to start with the plus up top and then go down. And then fill in across. Gotta be a little bit careful with this diagram. In the 4x4 case, so I started with the first column. So where was I? This is going to be 3 times some determinant. Which one? Well, that one, right? And that is all, right? Plus some zeros. Zeros with an E. Sure. Okay, so terms that will be zero, so I don't even bother writing them. Next. Well, you can see 4x4s are another layer of difficulty. Now I have to do a 3x3 determinant. Well, I'll use the first column again. 3 stays. Then I get -2. Let's be a little bit careful here. Square bracket. I get a -2 times the 2x2 . Okay, I'm putting this just for emphasis. You don't have to do that. Now, here's a common question. What do I put here? Do I put a plus or a minus? When trying to make that decision, do I return to this diagram? Or what do? The answer is no, you just forget. You just forget all about this diagram. And you treat this 3x3 as a standalone 3x3 determinant. You do its own diagram, which tells me there's a plus here. Okay, so at every step of the game here, I'm doing a 3x3 here. I totally forget about the 4x4 from earlier. And when I'm doing this 2x2, I forget about this 3x3. Just focus on what's in front of me. So 3 times -2 times 1 times 2. Now I want to point out that these are the diagonal entries of the original 4x4. Okay, that was the point of this example, to do a 4x4 and also to introduce a theorem. Does it have a number? Not that I'm aware of. The theorem says that if you have a triangular matrix, if A is upper or lower triangular, then the determinant of A is the product of the diagonal elements. Now, this is an example of an upper triangular. And then a lower triangular would be, pi, why not? E, even if there's a 0 there. I think I got that right. It doesn't really matter. These are what are called triangular matrices. It's possible I have them mixed up, but the point is that you have these zeros either below the diagonal or above the diagonal. So in that case, you can very quickly find the determinant by just multiplying the diagonal entries. Okay, one last thing.